Last time we were together, we filled out this 5 basic functions worksheet together. We found these graphs of these 5 functions that we're going to use a lot this semester. So hopefully from now on, when I say x squared, you're going to picture this parabola. Absolute value of x, we're going to picture that 90-degree V shape sitting at the origin. Root x being that sort of a sideways half parabola. And then x cubed, our snake shape passing through the origin, and then kind of the sideways flipped version of that for cube root of x. So now we're going to fill out this transformation rules worksheet. Okay, so this says if you know the graph of f of x, and then we've got a bunch of blanks to fill in. So let's head over to Desmos and play around with these graphs a little bit. All right, so here I have the graph of x squared drawn as a dotted line. And let's see, I'm just going to start playing around with the formula here and seeing what changes that makes in the graph. So I'm going to add a number to this. Let's say +3 and turn on the graph. All right, and when I added 3, look at what it did. It copied the exact same shape, but it just shifted it up 3 tick marks, right? So that bottom part of the parabola is now sitting up at a y-coordinate of 3. And so this should kind of make sense. All I've done is taken the y-coordinates and added 3 tick marks to all of them. So you might guess what happens when I subtract a number. So let's say I want to subtract, let's pick a new number, 5. And it moves it down 5 tick marks. Okay, so this is going to be our first rule that when you add a number or subtract a number outside of the function, then it's going to either move it up or down, and it moves it up or down however many tick marks you gave it in the number. All right, so let's write our first 2 rules down. If you know the graph of f of x, the graph of f of x plus c, so if you add a number on the outside, is the graph of f of x. Remember that shifted it up c units. All right, and then the graph of f of x minus c, when we subtract a number, is the graph of f of x shifted down. C units. And of course, the way I have this written, we're assuming that c is a positive number. We're not talking about if you add a negative number. We're talking about if you add a positive number or you subtract a positive number, then the graph is either going to go up or down however many units you added or subtracted. All right, so let's go get our next 2 rules. All right, for these rules, I'm going to use the absolute value of x graph just so we have something different to look at. And we already know what happens if I take absolute value of x and I add a number to it. It's just going to shift it up, or if I subtract, it's going to shift it down. Okay, so these rules are going to apply to all of those functions we know, and in fact, apply to all functions everywhere. When you add or subtract, it moves it up or down. So now I want to move the addition and subtraction inside the function, inside the absolute value bars. All right, so let's see, we started off with adding. Let's add a number. Let's add +2. All right, and what happens might be a little unexpected. So with the up and down transformation, when we added, it moved up. We subtracted, it moved down. That kind of felt intuitive. Here on the x-axis, adding inside the absolute value bar, so adding inside the function, moved it 2 units to the left when we added. It kind of felt like maybe if we added, it should have gone in the positive x direction. So let's see if this holds with subtraction. Let's see if subtraction will move it to the right. Okay, so I'm going to come in here and let's subtract, and let's pick a new number. How about 4? And yeah, when we subtract 4, it moved it 4 to the right. So it seems like this horizontal rule goes backwards of what we would like it to. The best way I can give you an intuition about this is to think about that point at the V that has a y coordinate of 0. So in order for this function, the x minus 4, to get a y coordinate of 0, you have to plug in a positive 4. 4 minus 4 is going to give you that 0 point on the graph. Likewise, when I change this to a plus, all right, you need to plug in -4 for x. So -4 plus 4 will give you that y coordinate that's 0. Okay, so generally it's just easier to remember that vertical transformations do what you expect them to do. Horizontal transformations kind of go a little bit backwards. All right, so let's fill this in. Okay, so this is going to be the graph of f of x plus c inside the parentheses. So this is like adding inside the absolute value bars or adding inside the square or adding underneath the square root symbol. So it's wherever the inside of your function is. If we add, we found that that shifted the graph to the left. So this is going to be shifted left, and C units, however many you added. Likewise, when we did subtraction, so this is going to be F parentheses X minus C, so we're doing it inside the function. This is going to be shifted right, C units. Okay, I'm just going to head back over to Desmos and kind of play around a little bit with these two rules to make sure we have our brains wrapped around it. Okay, so here I have this square root graphed. All right, so just to kind of get the point about inside and outside the function. All right, so if I add outside the function, let's add 3. Okay, it takes that square root graph and moves it up. Likewise, if I subtract 3, it moves it down 3 units. That's exactly what we expect. So again, we're doing that outside the function, outside the square root. If we want to affect a horizontal change on this graph, we're going to have to move inside the square root. So I'm now underneath the square root with the x, and if I do some addition, let's add 5, there we go. And again, adding feels like it should go to the right, but it actually shifts it to the left. All right, so it shifted it left 5, and let's just do one more. Let's subtract something. Subtracted a bunch of numbers. How about pi? There we go. So we've subtracted pi, and it moved it to the right, 3.14159 tick marks. All right, so again, outside the function has a vertical effect on the graph. Inside the function has a horizontal effect on the graph. Okay, we've got 3 more transformation rules to do. We'll do that in the next video.